This is my blog, one of them, Martian Math Storyboards. As of just after Halloween 2015, these are somewhat new pictures. Uh, these pictures are on Flickr, and then there's some YouTubes. I'm adding to YouTube this very moment. Let's see, by going into Flickr through my blog, which is kind of a trick not everyone knows, we get to this album called Martian Math. Um, which I want to open. Where do we see what album this is? It's not in any groups, but it's in storyboards, which is the name of the album. Groups is another feature. This is called Flickr. Flickr's free, or you can pay extra and have more privileges. I actually pay for my Flickr account. Now, I've been here before in videos. Let's get right to the heart of what I want to talk about today, though. And I don't want to take all of your time in doing it. Uh, Quadrays is what I'm looking at, and they're an important part of the puzzle when we talk about dimensionality. You may have heard that synergetics uses a somewhat different way of talking about how many dimensions does space have. We all learn at school that the answer is three: height, width, and depth. And Bucky takes issue with that, and he's like, what if we were taught a different way? What about another tribe in another culture that they just don't happen upon that particular way of talking about dimension, three dimensions? How wedded are we? How tied are we to that way of talking? Well, to sort of help with that whole question, I've created with friends. Actually, I shouldn't take too much credit for these. David Chaco really helped out, and I call them Chacovian coordinates as a result to some degree. Because of Chacovian coordinates, I'm able to bring up this question of to what extent are we wedded to talking about three dimensions as opposed to, say, four dimensions. Because Fuller talks about 4D. And what I'm not seeing in any of my comics so far is any explicit mention of these 4D coordinates. So let's just jump to where I do talk about these things, which is in Wikipedia. Here's your tetrahedron, and strangely enough, the four vertices of this regular tetrahedron are labeled with four tuples. In other words, instead of an XYZ, we're used to X, Y, and Z. Well, here, what I'll call the four basis vectors, let's call them that come from the center, the origin. They go to the four vertices of this tetrahedron. So that would be the origin where my little finger's pointing. It looks like Mickey Mouse's hand. Four basis quadrays to the corners of a regular tetrahedron, yes indeed. So these span space using all positive coordinates, and I show some interesting sums over here. If you add the vectors in very simple ways, you can get what conveniently turns out to be 26 points of interest, which maps directly to the concentric hierarchy as we talk about it in synergetics with these simple volumes for those shapes. This is what we call the Quadray coordinate system. And I've written a bunch of papers that are on the web that get into stuff about it. Now the Quadray, QUA and Quadray, and the QUA and Quaker, that didn't escape my attention. Being Quaker, I thought, hey, we could sort of brand this and give a boost to Quaker schools for their daring to get into this rather odd and abstruse kind of linear algebra, you could call it. And Tom Ace has contributed mightily in this area. I'm so pleased to see his 4x4 rotation matrices and so forth. So there's a developed literature here, which I recommend you look at, if only to further get into the question of the dimensionality of space. As you know, I talk about Carl Menger sometimes, and how he proposed a geometry of lumps, where a lump is like a lump of clay, you could say. And all our points, lines, and planes are distinguished, not that they're not lumps, they're all lumps, but they have different topology. Planes, as you know, are like rolled out. They're like dough that's been rolled out. And points are like little dough balls, and as little as you like, you know. It gets so small it goes off scope. Like you can't measure any closer together. So frequency is, going in to more small and out to big. We call that frequency. We keep that, but we call it all 4D because the tetrahedron really is the stand-in for the point. Not a sphere, because a sphere is just a point, whereas a tetrahedron has all the features that we want. It has edges and openings. So it becomes the primitive, not the sphere, and the unit of volume at the same time. So anyway, check out the web for more information on both quadrays and their context, which I would say is synergetic geometry. I do have a direct link to the synergetics page, and you'll see some of the same graphics. There we go. Whole number volumes and more of a breakdown into even smaller or more internal volumes within the tetrahedron and octahedron. We get the A and B modules, and then we can express our polyhedra in whole number sums of these guys. It's really second, third grade simple once you're over the hump. So I would recommend using Quadrays as a way in, whether or not you're in a Quaker school. Okay, thanks for listening, and I hope my headset proves to deliver good sound. Thank you.